files of that type. So by default, it only outputs malicious content. If you want to see everything, you would use the -v option. Or if you want to see the errors and additional information, use the capital -V. There's a graph mode showing the path, and this shows circled by red boxes whenever something is detected as malicious or suspicious by the rules. And this gives you some idea of the data structures that I've used. They contain a link type so that we can determine what type of detection we want to do on them. So one of the challenges I've tried to overcome with this is, of course, the infinite loops. So I put time limits on the script evaluations, and whenever it exceeds that limit, then I throw a warning. And in my experience, most of the malicious scripts are the ones that take longer. So the benign scripts typically are very quick to evaluate. There should be very few exceptions to that because they're generally assigning large amounts of data and doing heap spraying so that when the exploit is successful, it can jump to that address. But in those cases where it times out, we may not get the full decoding because it's based upon the machine being able to do that quick enough. And some of these exploits take, a minute or two to actually exploit a victim. The other thing that a lot of attackers are doing is profiling the user before they do things. And we can run every case of every version within this environment and determine which decodings belong to which version. So I'll show you an example, but these are the versions I'm currently using. And what happens is it'll evaluate the first one, and to save evaluation time, it will only evaluate the next ones if that first one didn't take too long. So basically, this is an effort to prevent it from taking several minutes to evaluate something. So this is an example of a PDF that I've included in my source code as an example. And this is a malicious file where the JavaScript uses a time-based decoding, and the set interval function basically says after 1,000 milliseconds, I want to set this variable to be X, where if it doesn't evaluate, it's still G. So the exploit here uses the annote PDF field, and if it does evaluate, then it'll translate the getAnnotes function into the xetAnnotes function. So the problem here is we define this app.setInterval, and if you evaluate it immediately, then this will not decode correctly because it's this xetAnnotes function is not a valid function. So to handle this, I try to determine whether to process the hook within the immediately or within the post-processing. And if it's a larger value that the time will take, then we delay it and we still execute it. But in this way, we can prevent it from doing these anti-decoding techniques. So this is a case of version detection. Basically, we see that if you set the PDF version to be version 7 or empty, we don't get any decoding. So it's not targeting those versions. If you target version 8, you get 234 bytes, and version 9, you get 144 bytes. So in this case, I choose to take the largest decoding. We could also process those other paths, but again, in an effort to reduce our time, we're not. So yeah, this is a Russian exploit kit, Zopac. And basically, to summarize, we have a lot of dynamic content that we can process. The HTML could contain get elements by ID and use the various things that are contained within the HTML. And to handle that, we have to process the HTML correctly and define the JavaScript environment dynamically based upon that HTML. I've also seen a lot of attackers using last modified and some of the HTTP headers that are available to scripts. So we have to process those, the PDF decoding. There's a lot of filters that I'm trying to implement and add to this file. And finally, the SWF triggers have to be interpreted to get the full picture. So how does this apply to intrusion detection? Right now, it's very dependent upon PCAPs. Even though you can run it as on a network interface, I don't recommend it because it's running as root, and I haven't performed a lot of testing on that particular feature. Right now, it's using libnids, which is a fairly well-tested library for intrusion detection. Once Snort and other IDS engines like Suricata can support this type of decoding, I think they're going to need multiple CPUs, and they might even require offloading the content or offloading the decoding, because the memory requirements for this type of thing are extreme, and it could affect other processes on the system. But I would like to add it to intrusion detection systems. Regarding inline mode and actually blocking the content before it hits the victim, I don't think it's practical to do that, but perhaps further testing would reveal that the benign URLs are actually going to be very fast in that case, and malicious ones are not. So it might be possible, but not likely. I think in the short term, probably a learning blacklist and just using it in a passive mode would be more effective. So I also have updated the web interface so that if you want to just use this without actually installing anything, there are a number of libraries that you have to install, libnids, several Python libraries, the Yara detection library. So if you just want to use it and you can just upload PCAPS files or URLs to my site. This is an example output showing the detection on a URL that was submitted. And I've decided to make all of my data very public. So in this case, you can download the zip file containing all of the logs, all of the decodings, and anything that this submission has created. I also added on the submission page a checkbox allowing you to submit things as private, because a lot of people have told me that they can't, they don't want it to be public. It could have a bad impact on their business. So a lot of what needs to happen is the rules themselves could be custom to your organization or whatever you want to detect. This is the RSS feeds that I've created from all my data, and you can subscribe to any of these and see which exploits are being detected whenever an exploit is detected. So yeah, I think this will be useful for tracking new vulnerabilities too. I plan on creating cases where we can determine that multiple decodings have occurred, but we don't detect anything, and fix those cases. So, any questions? Yes?
For the pre-cooking or the rules, is there any way to do some basic heuristical stack analysis? So in one case you said on the slide, you have an infinite loop while one, do blah. And so if you do some type of heuristical analysis, you kind of gather that maybe I should be using this particular version. Is there any way to do that in your rules currently?
So that's a very difficult problem. I tend to not want to modify the scripts.
Well, not so much modify,
yeah.
but just jump. Okay, because you're not going to be able to execute some idioms. So what you do is you just kind of say, oh, well, this says while one. I know this is an infinite idiom. I'm just going to jump past that or jump out of that loop.
It might be possible. I haven't looked into it yet, but that's a good point. Yes?
A lot of the malware I'm seeing is being downloaded through HTTPS. So what are your thoughts on really how did it handle, SSL, protected malware?
I haven't seen that many through SSL, but I think that definitely this tool would not be the ideal, because unless you set up a global SSL proxy and tried to, have a visible part of that, it's not going to happen usually. So I think what needs to happen is the browser engine. I don't know if you're aware of the Adobe solution to this problem, but in their corporate version, you can specify functions you want to disable. So I think the equivalent thing has to happen for the browser, so that you can define, I want to disable these functions, and the browser will never execute them. So that's more a protective measure, but in terms of detecting, I think that's not something I'm going to be able to do.
What if you integrated it with like a proxy like Fiddler or Burp or something like that?
Definitely, yeah.
Could you repeat that last question?
So the question was, basically, would what would you do in the case of